Hello everyone. In this video, I am going to talk a bit about frequency tables for quantitative data. So here I have quantitative data. I have 40 values that are measured in PSI for the strength of different samples of concrete. And I want to go ahead and show you what a frequency table is about. So there's obviously no categories when you're working with quantitative data, so you have to create numerical categories. And each numerical category is identified by a lower limit and an upper limit. These categories should all be equal in size, and they're called classes. So the first class is from 2490.0 to 2491.9. The second class is from 2492 to 2493.9. Then the third class, 2494 to 2495.9, etc. So each class is made of a lower limit and an upper limit. Each of the classes are mutually exclusive, so meaning there's no overlap, and they completely divide all the data into different categories so that every piece of data in your list has a class that it goes into. I have decided to use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes rather arbitrarily. I have some other videos where I talk in more depth about how many classes and how you can decide how many and how wide to make them. Here I just decided to do 10 to make things simple. I also, instead of starting at the lowest value here, oh, hold on, I see that this is not ordered. Before we go any further, we need to sort our data. So I'm going to sort this data, ordering it from lowest to highest. So notice I highlighted everything. I go to data, A to Z, sorts from smallest to largest. Okay, and now it is ordered. I didn't think it was ordered before. If it was, it didn't look right to me. So now we see 25095 is the largest piece of data, 2490.4 is the smallest piece of data. Notice I started my first class at 2490.0, just a little bit less than the smallest value in my data list. I could have started at 2490.4 and done things differently, but I decided to just make things kind of standard, start with all the lower limits having 0 in the 10th place, all the upper limits with 9 in the 10th place, and doing just nice even 10 classes. So the difference between these consecutive classes, notice it goes from 2490.0 to 2492.0. There's a difference of 2. That difference is called the class width. So the class width is the difference between consecutive lower limits. It's also the difference between consecutive upper limits, you'll notice. It will also be the difference between consecutive boundaries, you'll see, and consecutive midpoints, you will see. First, let's look at the boundaries. What do the boundaries tell us? Well, notice that there's a slight gap if you were to go to an additional decimal place. There is a slight gap between the 2491.9 and the 2492.0. It won't affect the data values because they're only to the 10th place, but in order to close that gap, we create boundaries, and boundaries are simply the value between an upper limit and the next consecutive lower limit. So halfway between 2491.9 and 2492.0, we get 2491.95. All we have to do to go halfway in between is just tack a 5 on to the end of the decimal in the upper limit. This will put it halfway in between. The class width is 2, so I could finish all of these boundaries by simply starting with the first one I typed in here and add 2, the class width. And then I can copy that down. And so we see the largest boundary, 2490.95, all I had to do was tack on a 5 to the 2509.9. Everything has a difference of 2 because the class width is 2. And ours was easy to see, but you could always take a lower limit and then subtract the previous lower limit, and you'll see there's the class width. Now, for the midpoints of the classes, these, well, they're what they say, midpoints. They're in the middle of the lower and upper limits. So to be in the middle, it's the same thing as taking an average. So the lower limit plus an upper limit, close the parentheses so that sum is computed before dividing by 2. And here's the midpoint, 2490.95. So the midpoint, you simply add the lower and upper limits and divide by 2. I'm going to go ahead and copy this all the way down, and there are the midpoints. This then is a frequency table where the lower limits and the upper limits combine to create the classes. So a class has the 2 parts and the boundaries and the midpoints. You'll notice what's missing, frequencies. How can it be a frequency table when we haven't yet computed the frequencies? So that's what we will do next. So down here, what I've done is I've actually combined the classes. I've rewritten them so that the upper and lower endpoints are in just one column to make the class. So it will be easier for us to make a histogram once we have our frequencies filled in. So how do we get the frequencies? There's the old-fashioned way, which is literally just scan through your data and count. So the first class includes everything up through the 2491.9. So we go over here and let's see, 1, 2, 3, 4. There are 4 values in the first class. So that has a frequency of 4. Then we want to go up to 2493.9. So 2493.9. That looks like it's just 2, right? 1, 2, it's 2493.9. Yeah, that's just 2 values. And so on. Well, instead of doing that, though, we can make use of Excel to count for us. And in order to do that, you do need the data analysis tool that is an add-in in Excel. I have explained how to get that tool before. I'll do it again briefly here. If you do not have your data analysis tool, you can get it by going to File, all the way down, then on the left bar of options, 2 options. So on this left bar of menu items, go to Options. On this pop-up on the left bar, you will see Add-ins. Click on your Add-ins. And then below you'll see here, Manage Excel Add-ins. You want to click Go. Then here are the add-ins. Simply click Analysis Tool Pack, which is the first one. Okay. And then when you go to your Data tab here, you should see your Data Analysis add-in package. So we go to Data Analysis, and we actually go to Histogram. Okay, so frequencies will be counted under the tool called Histogram. Input range is the data. Our data is from A2 colon A41. So everything from A2 to A41 comprises our data. Actually, see this thing labels? If I check that box, I can include the label as part of my input. So now this this A1 pressure will be counted as a label, and then everything after that will be data. Bin range. These are the cutoffs for when Excel is counting. Notice I was using the upper limits to count, but for Excel, we use the boundaries. And that is because Excel will not count a value equal to an upper limit in that class. It goes from the lower limit up to, but not including the upper limit. Mine, I have them written so that it includes the upper limits. So to make sure that if any values actually equal an upper limit, that it's counted and put in the correct class, we use the boundaries as the cutoffs for the bins. Since I checked the labels box, when I highlight my boundaries, I will also highlight the title boundaries or the label boundaries. Output range, let's come down here and put it by, well, it won't let me, so I'm just going to stick it up here. Or maybe it's because I wasn't in there. Let's see if that now lets me. Yeah, that was it. All right, so I'm just going to go ahead and put it right. Okay, I'm going to, oh, it won't let me do that. Okay, I'm going to put it here, right next to it. No, I changed my mind. I'm going to put it here. So I'm going to write over this. We don't want any charts, okay? I don't like Excel's chart output, so we're not going to use their chart output. Click OK. Yes, see, it's going to overwrite some stuff, but I'll say, yeah, that's okay. And here it is. So notice it relists all the boundaries, and then it gives all the frequencies. You want to make sure that if you have open, all your classes are closed, like mine are, that this more category should be 0. That will only have a value if you have an open-ended class, like everything else kind of thing, if you have like some really big outliers. Notice we had gotten the first two right, 4 and 2, and then here are all the others. Okay, so I'm going to draw a histogram based on this frequency table. So what you want to do is highlight the frequency column. So to make histograms, you are only going to highlight the frequency column. This will be on the y-axis, the vertical axis. So now we're going to go to Insert, Appear to the column chart. I'm going to do a 3D column chart. And here is a funky looking histogram. Let's see, my design menu, my quick layout. I like to do layout 8, closes the bars, gives me places for titles. I'll right click, go to outline, click a contrasting color. Now you can see the individual bars. The horizontal axis are going to be the classes. We'll be adding those in just a moment. Vertical axis, the frequencies. I'm just going to write FRQ, and this is a frequency histogram. So I'll just title it as such. And it looks a little weird here because we see it's not just going down, but it's popping back up again. That just happens to be that having 10 classes is really not the best choice for this data. Before I move on though, I don't want to forget to change the labels down here. So when I click on design, you'll see to the right there's a select data choice. Click on that. We want to change this horizontal axis. So go to where it says horizontal axis or the category labels, click edit, and now we need to highlight the classes. Oh darn, I forgot to do it. Let's see if it lets me. Yeah, so can I get in there? I forgot to move this out of the way. So let's do this again. Cancel, cancel, move the histogram aside. Now design, select data, horizontal axis labels, edit, highlight. Oh, I did it again. I don't want the boundaries, I want the classes. Notice though, when I highlight the boundaries here, they show up immediately on there. We realize, oops, that's not what we want. Cancel, cancel, move this histogram some more. There we go, we want these. Try one more time. Design, select data, horizontal axis, edit, highlight the classes. Notice not highlighting the label. I already wrote that there. Okay. Okay, finally, here are the classes. Funky looking histogram, though. Funky looking histogram. It looks like it is approaching a bell shape that it is, because we can see it's symmetrical. And if we had fixed these classes, we could have gotten something more bell shaped. Let me show you something else that I do show in another video, but since we are here, let's look at it. So that's what the weird frequency table looks like for these particular classes. The thing is, those are not the best class choices. Excel will create its own histogram for you, but not using the data analysis tool. There is now, when you go to insert under charts, this here, this little looking histogram, this one has different colored bars in the columns. Here's a histogram with all the bars are the same color. Notice you can have a histogram or a box plot. So we can have Excel make a quick histogram for us, and now it looks very symmetrical. It looks very symmetrical, bell-shaped, but thick tails kind of flat. In another video, we talk about this being platykurtic, meaning it is shorter and fatter than the normal distribution. And so to get this nice curve, Excel just used 4 classes, right? So you can see how they broke them down here. So this is Excel's histogram. I'll just call it statistical chart colon histogram. All right. So that is actually a nicer histogram. Although usually you want more than 4 bars, but this is suitable and it looked a lot better than our 10 bar, our 10 class graph. All right, so that's just a quick, kind of a quick preview or overview of frequency tables for quantitative data. And it's nice that Excel has this tool, this chart tool, where you can just make a real quick histogram, and it's actually much nicer than what we would have gotten if we just had Excel do it using the histogram.